All right, guys, so as promised, we're going to go over a couple of these equations here. So I'll start out with number one that was on our test sheet, and I'm going to quickly draw this in. Sorry, my drawing is not always the best. Got a resistor in here, and then another one in here, like this. And then I think it says our voltage is 12. It says it's not giving us our total current. We're going to solve for that. Then we got R1 and R2. Each of these is 4 ohms, right? This would be 4 ohms, 4 ohms, and we know we got 12 volts over here. So knowing this, guys, right from this point here, oh, sorry, switch things here. This point and this point each have 12 volts at it, right? So we got 12 volts coming around, 12 volts going to each branch. So you can use Ohm's law here, and 12 divided by 4 would give us the amperage, right? We have 3 amps on this branch and 3 amps because they're the same. And then we know that there's current coming out and it splits, right? And because we got equal amounts of resistance, we're going to have equal amounts of current going through here. So we can add those two together, and then what's coming back here is 6 amps, which means what's coming out of the battery is 6 amps, and then it splits in. So our total current, which is what the IT stands for, is going to be 6 amps. Okay. So let's start with, let's take a look at another one. Let me erase this. Find a better eraser somehow. Sorry. That was question 1 on the assignment we sent home. And then let's take a look at, let's step it up to a little bit more difficult one. Then we'll take a look at question 3, and I'm going to do the same thing here. Just draw out our voltage. This will be number 3. I'll put it up here in the corner. You guys can follow along. Another resistor. Here we got another resistor. Obviously, I should have taken some art classes. So for 3, it tells us that our voltage here is 12 volts. It's again got us solving for current. R1 in this case is 12 ohms, and R2 is 12 ohms. We're solving for RT, so we put the 12 volts over here. And then R1 and R2, you know, we got 12 ohms and 12 ohms. And again, like I said, you know you've got 12 volts on every branch. So this would be 12 here. We just use Ohm's law, right? V is equal to I times R. And so our voltage is 12. We don't know the current, but we know that our resistance is 12, like this. And if we divide both sides by 12, I equals 1. So these are each 1 amp. They're the same, right? This is 12 volts as well. And so we know we've got 2 amps coming out, 2 amps coming out of the battery, 2 amps returning to it. So our total current flow through this is 2 amps. Okay. So now, let me get rid of this. Bear with me, guys. All right, so then let's take a look. So this is on that first page, right? I got a messy thing here going on. Sorry guys, just trying to clean this up here. Find a better way to do that. Okay, so let's take a look at, let's see, number 5. Number 5 has more legs on it. Come on. The 3 resistors on this one. And battery again. So, and then for this is number 5 on that first. So on here, I'm going to try to do this a little clearer. It says that E is equal to 12 volts. And then it says IT, our total current. Listen, I'm sorry, we don't know 12 volts for number 5. Sorry. Trying to look at 2 different screens here, guys. We're going to solve for that, but we know that we got 12 amps here. And then it says R1 is equal to 2 ohms. And then R2 is equal to 4 ohms. And then R3 is equal to 4 ohms. Sorry, I didn't put the plural above that. Okay, so now we got this, and so we can kind of pencil in what this means. So we don't know, we know that R1 here and R2, try to be a little bit careful, and R3, we've got 2 ohms and then 4 ohms and then 4 ohms, right? And then we know the current right here is 12 amps, which must mean that there's 12 amps coming out of here. Okay, so based on that, now we've got to try to solve for what the voltage value is of this arm. So my first step here would be to let's find out the equivalent resistance of this, right? You might remember that that's RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So then I'll just rewrite this. So we got 1 over 2 plus 1 over 4 plus 1 over 4. And then remember that this is actually 1 like this, right? So, and sometimes people forget that. So something to just kind of keep an eye on. So I'm going to change these to decimals, right? I'm a decimal kind of guy. And then 1 over RT ultimately ends up equaling, well, 1. And then we'd have to do the inverse of this, so that we'd move RT over 1 would be equal to 1 over 1. So our total resistance would be 1 ohm, right? And that kind of follows along with our rules that we talk about in class, that the total resistance in this would be less. So now if we know that we got 12 amps going through the unit, right, total current, we can use Ohm's law in this case to solve this, right? And the way that we would do that, sorry, let me back up, would be voltage is equal to I times R. So voltage would be equal, right, to 12 amps that we've got, and that would be 12 amps times the what we solve for, total resistance of 1 ohm, so the voltage is equal to 12, right? So we could now put that in here as 12 volts. And then remember that at each point here now, we've got 12 volts. And this is an important part to remember, because once you know what you've got at each branch, you can determine the current, right? Because all we need to do, according to Ohm's law, remember our circle here, right? Volts over, just like this, right? So if we know the voltage and we know the resistance, we just divide it and that gives us the amperage. So 12 divided by 2, that means we got 6 amps coming through this leg. We know 12 total. Then over here, we've got 4 going in here, right, coming through this leg. So that's going to be 3 amps. And then this one would be 3 amps. And we know that this is correct because if we add this one, and this one together, we get this total number here, right? So we like that. That's good. All right, so let's take a look at one. Let's take a look at another one. That was 5 on that first page. So I guess now I'm on worksheet 2. So let's take a look at number 1. So worksheet 2, question number 1. I think that's what you guys are asking me to do. So again, I'm just going to draw this out. So we got 3 resistors again. I don't know why. I guess they like 3 resistors. Oh, they actually got 4. My bad. Sorry. Got a 4th one. It's getting challenging. So then I think what I'm going to do. Hold on a second here. I think it's better if I type this, right? It seems like it. So I'm going to put it like this. I can barely read my own writing. I apologize. So it says here E is equal to 12 volts. And then it says, looks like we're going to be solving for IT. So total current, right, in this. Oops. Total current. Current is unknown. We don't know that. And then it's got R1 is equal to 4 ohms. And we got R2 is equal to 4 ohms again. But then we got R3 equal to 12 ohms. 12 ohms. Sorry guys, getting myself a little confused here. R4 equal to 12 ohms. Okay. So we got our read. So let's. What I like to do is just kind of plug this in. Just makes it easier. So I'm gonna put our category R1, R2, R3, R4, and then this would be 4 ohms, 4 ohms, and 12 ohms, and 12 ohms, and then we got 12 volts here, right? And so we've got to solve for that total current that's coming out of here, and then of course we know it's got to be the same coming back. So again, I think what we want to do is solve for the total resistance, right? So we do the 1 over RT method, and then 1 over R1. Again, 2. The only thing is this time what we got 4 of them, right? So I guess that makes it a little more challenging. 1 over RT, and then we got 1 over 4 plus 1 over 4 plus 1 over 12 plus 1 over 12. And then we'll solve for this. Now, I think in this case, since we know 4 goes into 12, it might be easier just to keep our math simple and keep it as fractions. So this would be 3 over 12 plus 3 over 12 plus 1, right? Because the common denominator is 12, so. And then 1 over RT ends up equaling 3, 6, 7, 8 over 12, right? And then we got to do the inverse of this. So RT equals 12 over 8, right? And then let me grab my calculator real quick. You guys are probably sharper than I am. It's getting late for me. So let me just see here. I'm going to go 12 divided by 8. I get 1.5. So the resistance total is 1.5 ohms. So now that we know the resistance total in it, we can figure out the amperage, right? So our equivalent resistance is, again, it's less than our total. And according to Ohm's law, right, voltage is equal to current, which we're going to solve for, times resistance. So we've got 12. We don't know the I. We know R is 1.5, right? These are multiplied. We're going to divide by 1.5, divide by 1.5. And your total current, in this case, is going to equal what? Well, I'm going to take out my calculator again, and I'm going to go 12 divided by 1.5, and oh, it's 8. Okay, 8, wait, what? 8 amps. So that means we got 8 amps coming out. We got 8 amps coming back. And again, if you're trying to check your work, right, once you know this, you can kind of figure out if your branches work. So remember, each one of these points on here, right, this is all going to be 12 volts. We know this from before. Okay, so 12 divided by 4, that would give us 3 amps here, and 3 amps here, and then 1 amp and 1 amp. And if we add these together, right, what do you get? 8 amps. So we know that this is correct. We got 8 amps coming out, 8 amps coming in. So again, not too bad, right? Fairly easy. So let's take a look at, again, worksheet 2. And I guess let's do problem 3. So I'm going to go down here. Bear with me, guys. I know this takes a little bit of time. Just drawing the stuff is a bit time consuming. And this one's going to have 4 legs on it as well, I guess. I shouldn't have put that there. So there we go. 1 resistor, 2 resistor, 3 resistor, 4 resistors, right? Just like this. And then I'm gonna type it out here again so that we're all clear. So this says on number 3, E is equal to, oh, we don't know it on number 3. So it says IT is equal to what? 1 amp. It was like 1 amp, because usually that means it's somewhat simple. Then R1 is equal to 2 ohms. And then R2 is equal to 4 ohms. And then R3 is equal to, R3 is 6 ohms. 6 ohms. And R4 is equal to 12 ohms. Okay, so just like this. All right, so I'm going to go ahead and just plug in our stuff. We know we got, we've been doing this now a bunch of times, but let me try a different color. Make it, there's 1 amp. Again, I'm using a new program here, so I'm trying to understand how it all works. So thank you for your patience, everyone. And then I'm going to put down here our resistance. I'm going to put R1, R2, R3, and R4. And I'm going to change, this is going to be 2 ohms, 4 ohms, 6 ohms, and 12 ohms. So again, what do? Right? I want to solve for the total resistance of this, the equivalent resistance, right? So that's that 1 over RT, right, is equal to 1 over 2 plus 1 over 4 plus 1 over 6 plus 1 over 12. Now again, I look at this like, what's the easiest way for me to do it? Because I know the common denominator here is 12. I'm probably going to just keep the fractions. Otherwise, if I see it's a little messy, I usually go with decimals. So I'm going to just change the denominator to 12, which will make this 6. This one will be 3. This one will be 2. And then this one will be 12. And then I'm going to end up with 6 and 4, 10. It looks like what? What is that? It's 12. Oh, look at, sorry, hopefully this didn't confuse you. Should have changed my number there to 12. I knew that, that's why the numbers are what they are. So it would be 12 over 12, right? 1 over RT. We've got to do the inverse. We have to flip this, which ends up being 12 over 12. So the total resistance of this is what? Yeah, 1 ohm. 1 ohm. So now I know the total resistance of this unit is, again, just like where I have this, I can write in here 1 ohm, right? There's going to be 1 ohm of resistance for this total circuit. So if I use Ohm's law, voltage is equal to I times R. I don't know the voltage, but I know the current. I know the resistance is 1. Well, that came out pretty easy. Voltage is equal to what? 1 volt, right? So if I put 1 volt there, again, we know, and I'll try to use some different colors. We know at these points, right, that this has to be 12 volts, or I'm sorry, 12 volts, 1 volt, 1 volt at each leg, right? So if I multiply, or I take 1 volt, I'm sorry, not multiply, divide 1 volt by 2, which is our Ohm's law, I would end up with what? Well, yeah, 0.5 here, right? 0.5 what? Amps. And then over here, I would end up with something 0.25 of an amp, right? And then if I went over here, 1/6 of an amp is going to give me what? 1 divided by 6. Yeah, this is kind of, this sort of gets a little messy, but this would be 0.1666, then 6667, what, amps. And then 1 divided by 12, you probably hear my calculator, it's going to be 0.0833. So it just keeps going on, right? Yeah. So if I add these together, I should come up with what? 1, even though I got all these extremely large numbers. Yeah, and sure enough, when I add them up, I come up with 1, right? So that should get you through that one, number 3 on that circuit. And then we're going to take a look. Let's try another one. Let's try number 3. So worksheet 2, question number 3. Switch back to my black pen. So this one has only got 3 resistors. Well, that's good. See, what else would you guys rather be doing on a nice Sunday evening, huh? All right, so on this one, they are telling us that we have E is equal to what, 12 volts. Our current, in this case, is equal to 4 amps. And then R1 is equal to 12 ohms. And R2 equal to 12 ohms. And let's see, R3. Oh, these guys are getting sneaky, right? They don't want to, now they don't want to give us that third one. Okay. So there's our resistances, or our setup here. So I'm just going to, again, pencil it in. See, we'll put 12 volts here. And I think I was using green before. So we'll put R1 is 12 ohms. R2 is 12 ohms. R3 we don't know. And then we can just kind of pencil this in. This is 4 amps coming here, and 4 amps. 4 amps. Go. Gee, that was ugly. Sorry, guys. Sometimes I 4 amps like this. Okay. So we know what's going on here. We got 12, 12, 12. We got to solve for this third resistor. So it's a little trickier. Not much. It's going to be the same thing. We probably want to do what? Probably want to solve for the, well, 12 times 4 is giving us our amperage. So we know that at each point, here, here, and here, we know that this is 12 volts, right? So, um, we potentially could solve this a couple of different ways. First of all, since I know the voltage here, I know that this one's probably going to be 1 amp, right? 12 divided by 12 and 1 amp here, right? And I know I got a total of 4 amps, so if I got 2, this would have to be what? Yeah, 2 amps, right? That probably would be um, the way to look at that. And if you know the amperage, now we know the resistance. Well, 12 divided would be 6 ohms, right? You use Ohm's law in that case.